All right, I want to continue doing lines right now, and before we actually do the more, weighing questions, I wanted to go to a few basic questions. These will not come in the exam, as far as I can tell, but we just might want to skim through them. Now, the basic questions here is telling that the line is parallel to HP and is perpendicular to VP. That's the first question. Now, how is that going to be? Now, if this is my line, right, and it's parallel to HP, it is parallel to HP. In this sense, it is something like this. This is my HP plane, it's parallel to my HP plane, and it's perpendicular to my VP plane. So this, now if I'm assuming that this is my VP, yeah, that wall is my VP, then this is perpendicular to that wall, and this is basically parallel to the floor. So this is the line which is parallel to HP and perpendicular to VP. Now if I'm looking or trying to look at the front view of this line, I see only a point, right, which is exactly what I've written here. So the front view of this line is going to be a point. This is A, this is B, so it is A dash and B dash in brackets because we cannot see it. Now if you try seeing the top view, how do I see the top view? This is my line, I go over here. Now what am I seeing? I'm exactly seeing B and A, right? That's B and that's A. So that is exactly what we've written here. We've written B and we've written A. Now if I'm trying to look at the side view, now side view I can see both from RPP and LPP. For RPP we got this side, so this is my side view from RPP. And what am I going to notice? I'm going to notice exactly B. I'm going to notice B dash and A dash, right, which is B dash and A dash. But if I'm doing LPP, I got this side, I'm going to notice A dash and B dash. A double dash and B double dash, sorry. So A double dash and B double dash and B double dash and A double dash. So this is when the line is parallel to HP. Now if the line is perpendicular to HP and parallel to VP, that's my VP, vertical plane is parallel to VP. If I'm looking at it from the front view, what am I going to get? I'm going to get a straight line AB, which is exactly what we've written here. It's a straight line AB. And from the side view, again, either side, we are going to see a straight line. So it is going to be a straight line in either side. When I'm looking at it from the top view, which is here, I'm going to see another point, which is exactly what we've written here. It's going to be another point, AB. Now, if it is parallel to both HP and VP, it is going to be like this, right? So that means it's parallel to that and it's parallel to the floor. So it's something like this. But if it's like this and I'm seeing it from the front view, what am I going to see? I'm going to see a line. I'm going to see a line having A and B, right, which is A and B in the top view, and I'm going to see A dash and B dash from the front view. But if I'm seeing it from the side, what am I going to get? This is my LSV, so this is the right side projection. I'm going to get A double dash and B double dash in brackets because I cannot see it B double dash, but if it's an LSV, I see it from the right hand side, and I'm going to get B double dash and A double dash because I cannot see A double dash. So these are the three kinds of questions, very basic, and they would not be asking this. Now another kind of question is they might just say that the line is inclined to HP with a certain degree, in which case you first draw the points, you incline it to that 30 degree, and they would have given you the length of that line. And this is similar to what you would have done. Now this is the top view, so at a 45 degree I get at the top view and I go straight line and I connect them both for side views, and that is how you get the side view for this. It's basically, this is my HP, it's inclined like this, correct? Now if I'm going to look at it from the side view, what am I going to get? I'm going to look at it from here, let's say, right? When I'm looking at it from here and it's projecting something in that wall, it will be the length of the pen which is condensed to a certain degree, which is exactly what we notice here. And these kind of questions they will not give, so you don't have to worry about them. I just wanted you to go through them once and not skip them entirely. Now once we've gone to them, we'll actually get to the main deal. This is the structure for any kind of question they can ask in lines. What will they ask? Now first of all, you'll have to plot these points, right? They'll give you the dimensions. You can plot this point, you can plot this point. Done. Once you plot the point, draw a locus from that point. I draw one locus here, I draw one locus here. That's my XY line, by the way. Now, after I've drawn that, Now, the first kind of questions are all the forward projections. Now, what are forward projections? Forward projections is when when they've given us the true length, and we have to find the apparent length. Now, how do you do this? When they have given now, first of all, they would have given these points, and they would have given true length. Once they've given the true length, now they might say that the true length or the line AB is this much, like 50 mm, and you have the true length of it, right? And I'll just get to the question directly so you can look at it. So the first question over here, for example, here they've said the line AB 80 mm long. So first we've got the points. We've taken 80 mm long. This is the main line, and usually you express the true length as A dash and B1 dash. You don't say B dash, you say B1 dash. And same thing here, A and B1. You don't say B, you say B1. So this is 80 mm. So we're taking 80 mm arc. I cut an 80 mm arc, correct? And they've also given me the angle. It's inclined 30 degree to HP. That's my HP. It's inclined 30 degree. Now usually this small angle, the true angle here is called theta. Here the true angle is called phi. Here the apparent angle is called alpha. Apparent angle here is beta. So if they've given theta, which is 30, they've given the true length, correct? So with that I can basically get this whole length, and I can draw locus here. Once I've gotten this point, I draw one locus here, one locus here, one locus here. And they've also done it for the bottom part, by the way. 45 degree over here is phi is 45, and true length is same both in the top view and in the front view and the top view. So I do the same thing. I take 80 mm, I cut in 80 mm arc here, and I get the top view. So from that point, one locus, two locus, three locus, four locus. So 1, 2, 3, and 4 locus is there, right? When we have the true length and we have 4 locus, when you have true length, that point, whenever you have true length, you directly have to start taking a line. Now if you're drawing a line from the first quadrant, first locus, it always goes to the third locus. 1 locus, 2 locus, 3 locus. So this line will go from here to here. Okay, done. Now if it's going till here, I take a compass and I measure this distance, and I draw an arc here which cuts my fourth locus. So 1, 2, 3, compass, cut the fourth locus, and wherever that cuts, it cuts about here, right? Wherever that cuts, there's already a locus here, that will give my apparent angle below. So if I have true length above, I get apparent angle below. Now if I have true length below, this is my true length. Whenever you have true length, you directly start drawing a line. Now since this is the fourth quadrant, for the fourth locus, you draw till the second locus. So if it's the first locus, you draw till the third locus. That's 1 to 3 or 3 to 1. But if it's in the fourth locus, you draw to the second locus. So if it's in the second locus, you draw to the fourth locus. Now from the fourth locus, I draw a straight line to the second locus. That's my second locus. This is my true length from here to the second locus. Now once I get to the second locus, I take the length of that and I cut an arc in the first locus. So 4 to 2, and I cut an arc in the first locus. That will give my apparent length above. So true length below will give apparent length above. So if true length above, apparent angle below I can find, apparent length below I can find. If I have true length below, I can find apparent length above. Now how do I check if my answer is correct? Now if I'm drawing a straight line from the apparent point B dash to B, it is going to be a straight line. We call this has to be a straight line. That is the distance. This is one projector, this is one projector. The distance between these projectors is going to be constant. This is going to be a straight line. Now the true length need not be straight. They have the same length, but they need not be in a straight line. But apparent points are always along a straight line. This is how you check if the answer is correct, right? And you can measure the angles. This alpha, the apparent angle above, the bigger angle is the apparent angle, which is 45 alpha, and over here it's 55 beta. Theta is 30, and over here 5 is 45. So this is how you do forward projections, and this is what I've summarized here. When you have true length and you have to find apparent, you first directly draw a line, and the line, if it's from the first locus, draw till the third locus and cut an arc on the fourth locus. But if it's from the fourth locus or the second locus, you draw till the opposite one. If it's from the fourth, you draw till the second locus. From second locus, cut an arc to the first locus, right? So first you have to draw a line 1 to 3 or 2 to 4 or 4 to 2, right? It's usually 1 to 3 or 4 to 2. It's 1, 3 and 4, 2. You have to remember it that way. 1 and 3 are related and 2 and 4 are related. Now once you draw the lines, you basically have to take the measure and cut the arc, and that will give you the apparent length points, right? Before we go further, I also want to discuss on backward projections. So this is going to be a standard case of backward projection. What is happening here now? In backward projections, they will not say that the line is this much. They will say the top view of the line is this much, or the front view of the line is this much. Here they've said the top view of the line. This is top view. The top view of the line is 70 mm. So this is 70 mm. I've got the top view. Now the shorter angle is, so this is my, they've only given this. They've given this is 70 mm, and they've said and it makes 60 degree. This makes 60 degree, not the whole thing. The 60 degree with the XY line. The end Q. So this is the top view. The shorter one, which is the apparent one, is the top view. There's a 60 degree, right? And they said that the XY line, the Q is 10 mm front of VP. They've given the Q point also, and they've basically given these 2 points, and they've given the top view, and they've given the angle. So they've given us this much, and they've also said that these P and Q are separated 45 mm. So they're asking us to find true length and true inclinations from apparent length, obviously. So we have gotten Q dash point here, and they said that the Q dash and the P dash point are separated by 45. So if you take Q dash and take a 45 mm here and you draw locus, we already have this point. We have gotten the apparent length here, the degree here, so we've gotten this point, and you know that the apparent points are along a straight line. So if I draw a straight line cutting that 45 mm locus, I basically get my P dash point, right? So I get my upper apparent length and lower apparent length. Now once you have apparent length, you can find true length. How do you do this? You now once you're dealing with apparent length, the first thing you do is you do not draw a line. You first take an arc. You remember how with true length you would have drawn a line cut in here and then you would have taken arc. Here what you do is you directly take an arc and you reverse the process. I take an arc. Once I've gotten that point, this is the second locus, no? From second I go to fourth, 2 and 4, 1 and 3, 2 and 4. Second locus to fourth locus. Right, I draw a straight line to the fourth locus. That point will give me my true length. Now from my apparent length below, I take an arc, cut it. This is my third locus. No, third locus is the first locus. The third locus to first locus, I draw a straight line. That point is my true length. Is that simple? So whenever we're dealing with true length, if they had given us true length, you would have drawn straight line, taken measure and arc. But if we have this apparent length, you first take arc, straight line, and then that point. So it's the opposite, correct? If you have true length, first draw line. If you have apparent length, take arc and then draw line. But whenever you're drawing line, if it's from the fourth locus, go to the second locus. But if it's from the first locus, you go to the third locus. If it's from the third locus to the first locus, so 1 and 3, 3 and 1, 2 and 4, 4 and 2. Right, that is how you do backward projection. That's how we do forward projection. Here they've asked us to find true length. The true length is here 85 mm. The true inclinations, the small theta is 33 and this is 46. So another kind of problem they can give is they can give the DBEP, and I will discuss this. We will go to these 4 problems which I find really interesting.